So last we left off, I believe we talked about stoichiometry. Is that correct?
Yes.
Yes. And then we did some of the problems that you guys were having trouble with, if I remember correctly. We did 1 and 2.
Yes.
Right? Okay, good, good. Okay, so you guys can see how you use this flow chart here. Sit there and help you with that process. So if you're given a volume, right? You know, if you're given a volume of a substance, you can use the density to sit there and determine its mass. And then once you have the mass, you can use the molar mass. So if we have a volume, we can use the density to sit there and determine the mass. Then we can use the molar mass. Where do we get the molar mass from? Where do we get the molar mass from? The periodic table. To get the number of moles. Once we have the number of moles, we're going to use the balanced chemical equations to get our stoichiometric factor. And then that allows us to get the moles of whatever other substance that we're looking at. So we could be looking at another reactant, or we could be looking at another product. Okay. Okay, and then from there, if you need to get to volume or if you need to get to some other forms, you just follow around completely. So the key is that we need a balanced chemical equation, right? We know that we're talking about quantity, right? Quantity. And I did talk to you guys about quantity before, right? Talk to you guys about my sangria.
Yes.
The
I need a rush. I can't say.
recipe.
Yeah.
Didn't I give you the recipe?
Yeah, but I lost the page.
It's your fault. It's a one-time deal. Okay, so now let's talk about limiting reactants. Okay, I also call it limiting reagents because usually it's a reagent that you're working with. Okay, so when we talk about limiting reagents, we're basically saying that one of the items is actually. So let's talk about yield first, right? So the concept of yield, what does yield mean?
What you have.
What was that?
What you have.
So the production of?
Yeah. So like you plant something and then you harvest, that would be.
Okay, perfect. Okay, so it's basically what we're going to be making, right? So, and we know that that arrow basically gives us, we call it the yield, right? The yield arrow because it's yielding our products, okay? So when we talk about yield or percent yield, we're making reference to how much we're actually getting, right? Because did I tell you guys a story about when I was in undergrad? Okay, so let me tell you this. See, I forget the stories that I tell. So when I was in undergrad, I was taking a class. It was analytical chemistry. Analytical chemistry is just basically looking at how much you're making things, right? The analysis. So you put all of these analysis to determine things, everything like that. So yeah, the purpose of this lab was to determine what was the percent yield ultimately, right? And our starting material. So I had actually gone through and I had done the experiments and everything like that. And you know, I did it the first time and I got 84.6%. And I'm thinking, 84.6%, that's a B, you know, because 84, you know, that's not good enough, right? I want to get 100% because you know I want to brag and show off. And this is my wheelhouse. I'm good at chemistry. I've got A's in all my chem classes. This is my wheelhouse. I just aced the test. You know, my head was about this big and everything like that. So I'm like, okay, let me do this again. And I'm quick. And you know, bam, got it done. Okay. 86.5%. What the fuck, right? I'm like, livid, right? Okay, let me try one more time. Get it done. 84.5%. What the fuck? It's getting worse. It's not getting better. Something is wrong, right? So I go to my TA and I'm like, is there any way that I can come back? Because I know you teach, you know, in the morning and I know you teach in the evening. So I'd like wife come back to see me because I didn't finish it. I didn't quite get what I was expecting. So I want to try to do it time. And he's like, yeah, sure. And yeah, come on. Just come on back, right? I'm like, okay. So, I go and eat everything. And I'm hangry right now, because I wasn't getting the results that I wanted. And again, I was a little bit of a perfectionist, because I was feeling chemistry, right? It was my wheelhouse. This is what I know. This is what I want to do. I want to be a chemist. This is what I'm good at, right? And I'm like, you start telling yourself, you're like, I don't get this, then it should be in this. And then I, start getting into my own head. So I'm like, look, let me go through and I went through the steps. I wrote it down really precisely, check my numbers, redid the calculations. I'm doing this all while I eat and everything like that. So like, okay, I'm ready. So I get to lab, I have my lab notebook, and then I go through it. I go through it really fast. 86.4%. I am pissed. Man, my eyes are just getting like this big. Okay, so I go through it stepwise, check everything off. Maybe I'm doing something wrong. Maybe I'm just rushing it and I'm not measuring right. One more time. Okay, go through it one more time. Slowly go through it, check it off. And then I talked to this kid because he's actually in our big class, our lecture class and everything like that. He's one of these really rich kids. His dad paid for everything, he had a Porsche and everything like that. And he was just taking the classes because, hey, I'm gonna do something. I want to prove my dad that I can do whatever I want to do. Throw him as a fucking box of rocks. He's always paid somebody to do his exams. He's always did that. And so I talked to him, hey, and he's like, oh, I got 100%. And I'm like, this guy who's dumb as a box of rocks gets 100%. What the fuck am I doing, right? What am I doing? I need to get this right. So I am livid, right? I'm so mad at myself. I said, let me do it one more time. And then you really start talking to yourself. You're like, no, God, this is a sign. You guys have all done this, right? Before, right? God, this is a sign. You're trying to tell me that I shouldn't do this, right? I'm getting myself in far deeper than what I should be, right? And so I go through it and I'm like, real slow. 84.6% up fucking again. I'm like pissed. I throw my lab notebook across the room into the garbage can. I go and kick the garbage can as I go out. And I go out. Fuck this shit. I'm done. I'm gonna go quit. I'm gonna pack up, get in my car. I'm leaving tonight. Right? I'm just cussing, right? And my TA is like, Mr. Henry, what the fuck is wrong with you? And he's like, he comes out and starts talking to me. And I'm like, well, I did this experiment. And then I said, I kept getting 84.6%. And he's like, he laughs. And he's, I'm like, this motherfucker's laughing. So I'm like ready to fight now, right? So I'm like, okay, let's fight. We're going to have it out. I'm like, you're laughing at me? He's like, Mr. Henry, come with me. So he takes me to the back of the room. And he says, I want you to read the label on this. Look at it. I look at it. It says 84.6% pure. That whole fucking time, I'm getting almost 100% every time of what I was supposed to get, but I didn't know that, right? I made the assumption that everything was 100%. It was the perfect conditions. He says, this is a teaching lab. We buy the cheap shit, right? Like we do here, right? So you're never going to get 100%. He's like, if you get 100%, you're probably doing something wrong. He says, you may get 99%. Of what you're supposed to get, but you're only supposed to get 84%. That's all you were supposed to get. And he says, you did that. He's like, so why in the fuck are you bad? You're going to quit over this? And so he made me feel really bad. I'm like, I had my head down and everything like that. He's like, you're a good student. He says, you shouldn't be talking yourself out of that. And it's part of that concept. You guys heard about imposter syndrome. Have you guys heard of that before? Yeah. Right? We all fucking have it. And it's because we come from communities like this, small communities. Oh, my teacher must not be as good as other teachers. I'm telling you now, I am the best fucking teacher you will ever have. I will make your life as miserable as they will, right? And even more sometimes, right? I will make you work for it. You're not getting it for free. You're earning this, right? So that's the first thing. The second thing is, don't listen to fucking idiots, right? If they're telling you that they're getting 100%, they're lying, right? Because there's no way that you're going to get 100%. Because everything is slightly flawed. Either the percentage that you're working with. If you look at some of the chemicals that we have, the best that we can get right now is 99.9%. That's not fair. Meaning purifications. And those chemicals, those are safe for a very good day. It's not at this level. When you guys get to OChem, you'll start working with some of those, right? we had to wait for fucking months to get them because they were so backward. Because it takes so long to get those purified. So, and the other thing is that we also need to take into consideration, we're human. We're gonna make mistakes. That's part of it. If you're not making mistakes, then you're not learning. If you get everything's perfect, right, then you're a fucking idiot because you're never gonna learn, right? You need to make mistakes to sit there and learn, right? Sometimes it's those hard mistakes that make us learn so much faster than those easy, right? So, but get used to it. It's okay to make mistakes, as long as you learn from it, okay? Don't quit. Don't talk to yourself. Don't talk to Jesus and tell him you're trying to give me signs. He's not trying to give you signs. He's trying to get your ass in shape so you'll be prepared, right? So that when you do make those mistakes, you can just brush it off and pick yourself up, right? If you guys believe in Jesus, you know, whoever your deity is, you know. So I want to stress this a lot because that could change my life, right? Because I was this close, and I'm not lying. You can ask him. I should probably get in contact with him so he can tell you the whole story from his perspective. Because I made a fucking fool of myself. I was a little embarrassed to come back to class afterwards, you know. But hey, life is life. You've got to learn those hard lessons. So often we will be talking about percent yield. So you're never expected to get 100%. If you may get 106%, that's typically because you had a hair fall into the solution, you spit in it, such and such was talking and their earring fell in it, So things like that will always make it go over, right? But in most cases, you're going to have something that's less. And if you guys take a look at some of the work that you guys have done so far, right? You guys have calculated percent error, right?
Yeah.
Your percent error, did you guys get 0% error?
No.
Did anybody get 0% error? Right? No, we didn't, right? Some of you guys had some negative numbers, and some of you guys had some positive numbers, suggesting that, hey, we got a little bit more than what we're supposed to, or we definitely got a lot less than what we're supposed to. That's normal, right? And so, that's why I'm not going to sit there and rip you apart, because you get that 100%. It's not realistic. When we plan out experiments, when we're synthesizing a product, right? They never expect to get 100%. It's usually like 60 or 50 or 70%. You want to optimize it so you're not wasting your materials, but you have to be realistic because there are often things get clogged up on the sides. You're not getting good mixing. There are 50 million reasons why. And it costs them so much more money to sit there and get good mixing, to sit there and do it, that they're not going to do it. At the end of the day, it's about the dollar, right? And so they will shortcut their way to everything. We had this one process. I mean, I'm not kidding. If we got 15%, right? 50% yield, we were happy, right? And so, but we had it set up so that we would just refeed everything back into the system. So you're just constantly just getting 15%, And so eventually you get your product. Because if we tried to get 100% or close to 100%, it would cost us, 50,000 times more. 50,000 times, not 1,000, 50,000 times more to do that. They're like, hell no. We proposed it, but they're like, we want to make a profit, not sit there and give you money, with our product. Here, you take it for free, right? That's the way it works. So you got to be realistic. So we were calculating percent yield. We need to calculate what we actually get. So we call it the actual yield. Over the theoretical yield, or we call it the ideal, times 100. It's over. Not let me. right? So that's going to equal your percent. So your actual over ideal. Now your ideal is what we're calculating, right? Under perfect condition, if we have everything perfect, we have 100% of this product. This is what we're expecting to get if it was perfect under perfect circumstances. But reality is what we actually get. Okay, you guys understand? Don't worry, we'll do a problem, I promise. But I wanted to introduce you to that. And I also wanted to tell you my story because I think it's a great story to tell, right? Did you learn anything? Hopefully you guys don't do the stupid things that I do. How many of you guys have already done that? Yeah, sometimes. How many of you guys think that you don't belong? That you're not really meant to come?
Well, I was like,
That was you. I'm not meant to be in college, yeah.
for starting,
Yeah.
getting into it.
Yeah, you're looking at all the people around you. Oh, everybody's smarter than me, right? Oh, they're so much smarter than me, right? You guys need to get out of that habit. You guys are getting a really good foundation. Plus, it's kind of better here too, because you guys are not in a class of hundreds of students. My first chem class, we had 250 students. We would sit in this lecture hall, teacher would be down at the very bottom, we'd be all up, you know. And so like kind of like those movies you see, right? The periodic table, big ass periodic table on the wall over here, right? And then you're like this, and you're just like, oh shit, you know. And then first day of class and everything like that, they teach you guys out loud and they put you in little groups and everything like that. Not to your left, to your right. One of you guys aren't gonna make it. In my class, they were like, look to your left, look to your right. Two of you guys aren't gonna make it. I'm making it, right? So, I mean, literally, my class started out for chemical engineering. We started out with 100 students, first day of class. By the time we got to our sophomore year, starting off our sophomore year, we were down to 60, right? By the time we finished our sophomore year, we were down to 10. My class was a size 10. So when they said look to your left and to your right, they were just like, yeah, none of you guys are gonna be here. I mean, it just dropped like that. So the thing is that what I tell you guys now, I'm telling you from my personal experience, right? From me going to college, from me going into industry, right? As well as going to grad school and all that shit, right? Find a good study group, like what you guys are doing. Perfect. That's gonna get you through. That will get you through all 4 years easily. Get that study group. You guys do that group chat, right? I'm like, shit, I wish, man, if we had group chat, I'd have known every fucking thing. I'd have aced every test, right? And so I'm like, man, you know, you get that good foundation because what it is that group pushes you, right? It makes you driven. And you're gonna end up taking all the same classes pretty much, especially in the beginning. And then when you get into those upper division classes, you do exactly the same thing. Of course, you're competing, right? Because it's about competition. Make it friendly. I bet you dinner, I'm gonna kick your ass on this test, right? You know, something like that. I'll cook, you know, or whatever, you know. So just keep that competition because reality is that you guys are gonna be competing, right? And it's better to compete with friends rather than enemies. Believe me, I have my enemies too. I'm gonna kick your ass, you know. But you know, the thing is, it helps you get through that moment, okay? And so that's good. You guys have already got the right mentality. Keep that mentality. And when you guys start going to your new schools, again, go to the schools. You own that campus. This is your campus, and you belong there, right? Anybody that tells you you don't, tell them you can kiss my ass. You can keep kissing my ass because you're gonna always be behind me when you get the grades, right? And I'm gonna be on top, right? And tell them that. And I did. I told a couple of people that. I had a guy. It was I was still staying in the dorms in my sophomore year. We were taking a class together. I think it was Cal. I can't remember. It would be the equivalent of Cal 1B, and I was taking it my first quarter at UC Santa Barbara because I was ahead in calculus. I skipped a couple of things. I did the AP test for Chem and I did the test for calculus. So I got to skip my first quarter of calculus. So I was a little ahead, and this guy, he was just so fucking cocky, so mean. You know, he just like, and you know, at first I'm like, he's smart. He was smart. I'm not gonna knock him. He was a smart guy. He knew his shit, right? But I would go to him, hey, you know, I'm having a little trouble with this. And he'd be a dick about it and everything like that. And he would help me. And then my roommate and him were like tight. They were really tight. So he was talking shit, and then my roommate kind of checked him because he's like, you know, well, my roommate be fucking honor. What did you do? Right? Kind of checking him that way. And so, but he tried to, knock me down because, my roommate checked him and everything like that. But I said, I'm not worried about it. I said, we'll see. I said, we'll see at the end of the semester. I said, you may have gotten a better grade this time. I said, but I promise you, at the end of the semester, I'm kicking your ass. You're gonna be I promise. And so we made a bet. I won $100 real quick. I'm a gambling man. I've always been a gambling man, if you can't tell. And I'm like, yeah, this motherfucker, because it pushed me that even more. Because I'm like, he was, it's like he had such a big fucking head. And he was very privileged, and he used his privilege for everything he could possibly use it for, right? And you're like, this motherfucker, right? He made this one comment, right? He made reference to, you don't belong here, right? Your people need to stay where you belong, right? I'm like, your people, first off, your people, right? Motherfucker, do you know my people? I said, we come from Texas. Do you know my people from Texas? Right? You say, I need to stay where I belong, right? I'm like, okay, yeah, we're gonna fix your ass real quick. Right? So it felt good too. And then afterwards, every class that we had together, guess who was coming to ask for help, right? Yeah, taught him a real good lesson. So, my people.
So keep your enemies close with us.
That's right. Yeah. You don't need to burn bridges. And let me tell you, to this day, anytime that opens up, he's like, what are you doing right now? Like, please open it up. I said, hey, you want to come and work for us? And I'm like, first off, I'm not working for you, right? So let's get that straight. So okay, that aside. Now let's talk about limiting reagents, and then we'll go back to percent yield because they kind of go hand in hand. So, have you guys ever made a cheese sandwich?
Yes.
Yeah? Yeah. Okay, good. Okay, so this should be real easy. I make cheese sandwiches. I used to always make cheese sandwiches. Forte. I'm an expert. That's why I learned how to cook. I learned to cook at about 4 or 5. I used to make all these cheese sandwiches, pickles, and everything, right? So, but my family is a pretty big family. So I should say my extended family is pretty big. I have 2 sisters and everything. But my extended family, and at the time when I was younger, we were all staying with my grandparents, right? Because just like in most cultures and stuff like that, most people don't want to leave. Their parents kick their ass out of the house and stuff like that. You got to get a job or you got to get out, And so, literally, my mom had 9 brothers and sisters, right? So she was the oldest, 9 brothers and sisters, and so we were still staying there and everything like that. And my dad had just gone out on the boat. He was far away and everything like that. So she wanted to come back home to the family that to help raise me. So I would always make little cheese sandwiches for everybody, right? It was specialized. What do you want in your grilled cheese sandwiches? Grilled cheese, right? Bread, and pickles, right? So that was my special pickles. Right? So, but I do it for everybody, and like that. So I learned really quick about limiting reagents. So a limiting reagent is when you don't have enough, right? So if we think about it like this. So if I have 28 slices of bread and I have 11 slices of cheese, what's going to be limited?
The cheese.
Why?
Because you have 14 pairs of bread, but only 11 slices of cheese.
Right. Okay. So because we know for cheese sandwiches, the recipe is for every 1 slice of cheese, we use government cheese. So we eat those big old chunks of cheese. We'd use 2 slices of bread, and then that would make 1 sandwich. Okay. So if we had 11 slices of cheese, big old block, we're cutting 11 slices of cheeses, right? Then everybody would get a sandwich, right? But we'd have some bread left over. So nobody could get 2 because we didn't have enough what? Cheese. So the cheese would be limited. Okay. Now this is the same thing that happens in chemistry. Often, when you're working with batch reactors, you may have excess of one product that's real cheap, and your limiting product is usually the one that's most expensive. So you want to make sure that you're optimizing your batch reaction and that you're making the most products you could possibly get, right? And so you would always have one of those items that are going to be put. Okay. So let me give you an example. Okay, so here, if we have 3 moles of hydrogen gas, and 2 moles of chlorine gas. Now, we've already put it in the concept of moles. We know that moles is that mass or is that quantity? Quantity. We also know that our balanced chemical equation is based upon mass or quantity. You guys over here, what's that? Quantity. Yes, it's based upon quantity. So we know that we have to get to moles to sit there and determine quantity. We can also use molecules, but you're trying to keep track of molecules that make it boring real quick, especially because the numbers are so damn huge, right? So we always want to try to get it to moles to make it easier for us to understand. So moles is our gateway drug. Okay, you guys understand that? So if you're already given moles, you're already set, right? You get to go and use it immediately. But if you're not, you've got to work to get to moles, right? Okay. So which one is limiting based upon our chemical equation? So we look at the ratio. We have a 1-to-1 ratio, right? So for every 1 mole of hydrogen gas, it requires 1 mole of chlorine. And then that's going to make 2 moles of hydrochloric gas, hydrochloride, hydrogen chloride gas. Okay, so what would be limiting? This one should be straightforward. Is it going to be the hydrogen or is it going to be the chlorine? Okay, chlorine is going to be limited, right? Because how many do we have? So that means that I will need how many of my hydrogen? 3. I will need 3. Yeah, we have 3 in total, but how many do I need for a complete reaction? 2, right? Because it's a 1-to-1 ratio, right? So because we have for our chemical reaction, which is balanced, right? This is not our chemical reaction. Because if we have 3 moles of hydrogen, right? And we have 2 moles, that's what we're starting out, right? So we're starting out with this. This is how much we have. It's kind of like the bread and the cheese, right? So the ratio is 1-to-1. So if I have 2 moles of chlorine, how many moles of hydrogen will I need to react? I will need 2, right? And how many do I have? I have 3. So who's limiting? Chlorine, right? Because if I started out with 3 moles, if I decided I'm going to try to use all the moles of hydrogen, right? I start out with 3, then how many moles of chlorine will I need? 3. I would need 3. Do I have 3? No. No, because it's limited, right? There's only 2. Does that make sense? Yeah. Okay. Now we want to be able to do this mathematically, right? You need to show it on a piece of paper, right? So the way that we would do that is either A, you can do it by doing comparisons of your hydrogen to your chlorine. Okay. So let me show you that. So if we started off with hydrogen, we have 3 moles of hydrogen. We look at our chemical equation, we have a 1-to-1 ratio. 1 mole of hydrogen. We have 1 mole of chlorine. So that means that we would need 3 moles of chlorine. Now, the way that I write it out, I say, so this is what we would need, right? So this is the amount we would need. Starting with the H2. And then this down here is the amount that we have. Okay, so is our need greater than our half? values here. This is the amount that we have. This is the amount that we need.
Yeah.
So then that clearly tells me, right, that that is going to be our limiting reactant, right? Because the amount that we need is greater than the amount that we actually have, right? So that means that this guy is our limiting reagent. Okay, you guys see that? I mean, it's real simple here because it's all nicely worked out. Numbers aren't crazy. Okay, not too bad. Okay, so let's see if we can make it a little challenging. Oh, so the other way of doing it is working it out to figure out how much product we're going to get. And for me, I'm always looking for the easiest way, the quickest way of doing it, right? So if I do have to work out for each of them, that's twice the amount of work I do, right? And I don't like doing twice the amount. Especially if I just want to know which one's limiting or not. But if I need to figure out the numbers for something else, I may do it. Okay, so if I wanted to figure out my product, then I could just go ahead and figure out my product for each one. So if I start off with 3 moles of hydrogen gas, we know that the ratio of hydrogen gas to hydrogen chloride gas is a 1:2. So then I use that ratio, multiply it across. So then I need 6, I will make 6 moles of hydrogen chloride gas. If I start off with the chlorine, I'm going to make 4 moles of the hydrogen chloride gas. So we can clearly see that the chlorine is going to be the limit, right? Because it makes less hydrogen chloride gas. And so a lot of people like doing it this way. Me, I like doing it the other way because then I told you, I try to find the quickest way of getting it. Time is money. Questions? Concerns? Okay, this is just basically showing you one's limiting, one isn't. Okay, so let me get to a problem. We'll do the door. Okay, so if you guys go to active learning, it'll be up here in a second. It'll say limiting reactants. Mauricio, can you do me a favor? Can you go to the chessboard and they're having a meeting about the day of the day updates? Go over there, say, "Thanks." Go ahead and sign up. No, you don't have to sign up. I already signed up. Oh, you got a new show. They're at the chessboard. They show up? Yeah, just show up. They should. They might be gone, but I think they should. Oh, yeah. You need another one?
Yeah.
Okay, so did it show up for you guys? also come back to talk about particles. Are you ready? Batteries. So.
So it's called limited reactance up here?
Yeah. Did it show up in class activities?
Yeah.
Okay, it says if you have 5 moles of cobalt 2 chloride and 2 moles of sodium hydroxide, what is the limiting reagent in the reaction? Hold up.
Sounds already balanced.
Always check it to be sure. Okay, so how would I figure that out? You guys want to do it the long way or do you want to do it the short way? Like the long way. Okay, so if we have 5 moles of cobalt chloride. So we do a direct comparison between cobalt chloride and the sodium hydroxide. So for what is the mole to mole ratio of cobalt chloride to sodium hydroxide? So for every 1 or for every 2 moles, of NaOH, we have 1 mole cobalt 2 chloride. So if we start off with the cobalt chloride, we will need 10 moles of NaOH. How many do we actually have? We have 2. Is it not big enough? Do I need to make it bigger? So we know that sodium hydroxide is limiting. Everybody agree? Anybody disagree?
Yeah.
I said, do everybody agree?
Oh, yeah, I agree.
I just turn on.
Yeah.
Okay, so I'm not crazy.
When it comes to checking them both out, is there a reason why you go after the COCl2 first?
Nope, I could have went the other way.
Whichever one ends up greater than what you actually have.
Yeah,
It's limited.
that's right. So you just do, all it is, you have to get up. So I always tell students, I say, you want to compare apples to apples, right? So in other words, I need to compare my sodium hydroxide to sodium hydroxide, okay? Because there's a tendency, our first instinct is to say, oh, sodium hydroxide is the one that's the least, so then it has to be the least. Well, you need to show that, right? Because sometimes it'll fool you, right? Hopefully I can put that. Are they gone? Yeah. Okay. Do me a favor. Go to the manager. She would be taking. So the cap. Yes. You know where that's at? Yeah, I know. Just a minute. Yeah, she would do that. She's a. Yeah, say, you know, we missed the update. Yeah. Okay. Are you guys ready for the next one?
Yes.
Can I do that?
Dr. Henry, can you repeat? I know we're already asking this, but you asked like, how did you know to start with like the cobalt?
I didn't, I just.
So
picked
if
one.
you would do the 2 moles of sodium hydroxide, you would still get less.
Yeah, so, well, if you started with the 2 moles of sodium hydroxide, you would have less, much less cobalt chloride than what you have. So you would know that that would be excess. So you could choose either one. Does that make sense? Yes,
It's a,
it's A.
I think so.
You're not even letting me finish.
Oh, yeah. Valid.
So how did you figure it out?
Guessing.
Yes.
Okay, so you just guess.
I got lucky.
There's no, you can't just guess. There's not usually a multiple choice answer.
You're right. Most questions.
Okay, so how would you do it if you weren't guessing? Where would you start out?
Well, I don't know. I think you just got it right.
Okay, we're gonna teach you from doing that.
I'd
There's
rather
gonna be-
learn.
there's gonna be a very valuable lesson to learn.
Yes, I rather.
So, okay, so we're gonna work through it. So in this case, you have, as soon as you know that you have 2 reactants, right? And they give you values for both of your reactants.
Yeah.
Then you know that it's a limiting reagent problem. So the first thing that we want to do with everything that we're dealing with is stoichiometry, right? From here on out, pretty much everything. If it's not in moles, we have to change it to what? Moles. So the first thing that we want to do, we want to change them both into moles. Okay, so how would I change the iron into moles? So 105.2 grams divided by, what is what is the 55 point what?
845.
$55.845 grams. One mole. Okay, and then that would give me my moles of Fe.
Yeah.
Okay. So, because I always tell you, you have to be comparing apples to apples, right? So let's go ahead and figure out, based upon this chemical formula, what is the ratio of Fe to sulfur is? So what is the molar ratio, mole to mole ratio? For every 16 moles
Oh. Fire.
of iron, I have, how many was 3 moles? So
Oh, okay.
So somebody do that heavy lifting.
I got 0.35. Could have made a mistake.
Wait, can you repeat it?
I got 0.353.
Okay, so we have, it should be 4 sig figs.
Yeah.
Right, so then it should be set
0.353.
0.353.
You guys get this?
Yes.
So we also have our sulfur. So we have 95.2 grams of our sulfur. So what is the molar mass of sulfur?
32.06.
Times 8. Two hundred
56.48.
8 That's grams. Eight. So that would equal
0.3712.
so in this case, this is 3 sig figs, right? 7. 7, right? 3 sig figs.
No.
Okay, and then that would be moles. Of S8, right?
And the bottom one is FE.
No, this the bottom one is also S8. So this is how much we need, right? So remember when I told you about the need and what we have? Okay, so this is what we need to react with all of the iron. So this is what is needed. Sulfur needed to react with all iron. This is what we actually have. Okay. Sulfur. Sulfur we actually have. So we actually have 0.371 moles of sulfur. And we only need 0.3532 moles of sulfur. Okay, so what is limiting? Iron or sulfur?
You have abundance of sulfur, so iron.
That's right. So if we look at our numbers, so this is what we need to react, this is what we actually have. So we know that we have an abundance, an excess of sulfur. So then that means our iron is limited.
Yeah, iron.
Okay, does that make sense?
Yeah.
Okay, so you can't just randomly choose something, right? I know it's a 50-50 chance, but I'm gonna make sure it work. You can't just say.
Two reservations. That's still not specified yet. That is gonna have all these years. Not just have the email app. And then you can bring it to.
What size?
So I mentioned that.
Yes, and are there limitations? Limits as well. Last time.
But we still don't have.
Okay, you guys, how do you feel? Need another one to really get it in. I'm looking at you. You're not gonna answer. Okay.
I'll plead the.
Fine, that's right. I'll meet you.
This one was kind of easy, so I'll say we'll need it.
So I need to pick one that's really hard.
Oh,
No, I can just guess.
Sounds familiar.
Oh,
Okay. Yes.
Question. So
Oh,
I
did I
don't know
need to go back?
because you wrote them down,
Yeah.
but if like we had to we'll figure it out on our own, how would we know which one's the one we need and which one's the one we have? Like on the equation line.
Okay, that's actually a very good question. So what you need, so if you look at what I did, right? I took iron, right? I took iron. I could have stopped with the moles of iron, right? But I knew that I was going to compare, because I told you I want to compare apples to apples, right? So if I'm starting with the moles of iron, then the other product is going to be what I need, right? So, or the other reactant, right? So in that case, sulfur is going to be what I need. Since I started with the mole of iron and I got to the moles of sulfur, that's going to be what I need. So, and then in the other case is that's what they're actually giving to you. So what's given to you in the problem, right, is going to be what you have, right? And then what you calculate from the other guy is going to be what you need.
Okay.
Does that make sense?
Yeah.
So in this problem, if 2.00 moles of that would be butene. So it would be like 2 butane or some butene. So 2 moles of butene. And whoever wrote this problem was thinking of many things at the time. So you have 2 moles of butene and you have 10 moles of oxygen reacting in the following reaction. How many moles of which reactant would be left? Okay. First thing that we notice, do we have to do anything to our samples? So we already have it in moles. So we already have it in moles. So we can already start with that comparison, right? So since we have it in moles already, so how would I do my set of my comparison?
You start out with the 2 moles.
Okay, so let's start with 2 moles. So 2 moles, 0.00 moles of butene. And I want to compare those to what?
Carbon?
What is my other guy?
Oh, 10 moles of.
So I want to figure out what is the relationship with oxygen, right?
Yeah.
So what is my mole to mole ratio? 1 to 6. So for every 6 moles of oxygen, I have 1 mole butene. Okay. So that's 12 moles. 3 sig figs. 0 moles of oxygen. Okay, so this oxygen down here represents what? Is that what I need or is that what I have?
What?
It's what I need to react with that butene. And then this here is,
What we have.
that's what we have. Okay. Okay, so is it limiting? Is oxygen limiting or is it in excess?
Excess.
Okay, how many of you guys say limiting? Raise your hand. I said, is oxygen limiting or is it in excess? How many say limiting? Raise your hand. If it's limiting, raise your hand.
Wait, oh, I think I voted for one.
Limiting. Okay, now this is what we have.
Yeah.
This is how much we would
Oh,
need.
yeah.
Oh, that's my bad. I reversed.
Yeah,
Okay.
I changed my vote.
So this is what we actually have, right? And this is what we would need if we were reacting with all of the butane. So which one is limiting?
Oxygen.
So oxygen would be limiting. Okay, how much would it be limiting by? It would be limiting by 2 moles. We'd be short 2 moles, right? Now, but the question is how many moles of the reactant would be left over? That's the hard part, right? So we need to figure out how much is going to be left over. So in this case, we're going to have to do both ways, right? We're going to figure out. We're going to have to figure out if we started out with oxygen. So, yeah, 10 moles.
Just to make sure if we have any leftover of the oxygen. Or of the.
No, because it's we know that we know that the oxygen is limited, right? We need to figure out how much of the chlorine, not chlorine, of the butene that we're going to actually be using. So, because that's how we figure out how much. This seems like one of the problems that happen. Although I think you start with ranges.
You gotta really look at the vocabulary.
That's right. So for every 6 moles of oxygen, you have 1 mole of butene. I'll move it over so you guys can actually see it. Bless you. Okay, so then that would equal
0.66.
hey, it's becoming contagious. I get sick, you started.
Yep, that's right.
Okay, so then that would be my excess, right?
Yeah.
Yeah.
Oh, I see.
Because we subtract 2
Yeah.
from, so it's 2.00 moles is what we actually have, right?
Yeah.
And then we're going to subtract that from 1.66 because that's what we need, right? So 0.33 moles is going to be in excess. Okay.
So if it wasn't looking for like, because this one's looking for the reactant left over. If it wasn't, it wouldn't say reactant left loss, like I said.
Yeah, they're just telling you that's more work. They want you to do more work. So how many moles of which reactant is left over? Does that make sense?
Yeah.
You guys want to do one more?
You gotta find the limited nature regardless, but then that's that next step after.
That's right. That'll be your next step. One more? Yeah, Mas? Make it one more challenge. Shot. Look around me there. Relatively easy. See, there's my challenge. Okay. Okay, so there should be a fourth one that shows up. Hit refresh. Got it.
Jennifer said she wanted for lunch. Battery.
Well,
But
yeah,
the share, there,
yeah,
they mentioned that.
yeah. So the thing is that so we actually.
That was more time than half.
Sorry. Understand. Huh?
Okay. Their class starts at 1. Tomorrow morning.
Like I asked the whole semester.
Oh, Tuesday. That was in 5 minutes.
Okay, so you guys, where we're gonna start? We already got it done.
We have. Do we start with the milliliters or we start with?
Is milliliter moles?
Oh, okay.
Look at that nice target view.
I'll give you guys.
No, yeah, Moses. But yes,
I said is milliliter moles. You said no. Yeah.
It's not that. Second sequence of chemistry.
I can smell that.
That's
fine. That is fine.
Yeah.
Oh, there it is.
Yeah.
Just goes, all right, if you got it, you got it. Just that point. Yeah, the solid. That's the exam. How's that?
It's.
The DNA from the technical box. Yeah. Identifies the sequence of different tests. So you have to figure out. Oh, I something about the DNA. Just by looking at the image.
Sequences on.
Yeah.
I see what you're saying. Somebody's kind of thought about it.
No, it's one of the previous ones. Like the first 2 weeks. For the drop date with the W transcript. He's like, man, because they take an exam for the first 2 weeks.
You're right.
He's like, nah,
That's good. You read the
Yeah, you
whole
know.
thing.
yeah, like
Yeah, it smells like dry. though.
You don't smell like, yeah. And I'm just not like chapter.
It was like the intros for the food. Doesn't understand. Feel like a break off.
I checked it.
Yeah.
I mean, it had very much.
Because that's the most important. And 1A and 1B. So it's it.
No, I know.
So there's no one that can be in this.
Okay, you guys ready? It's all right, we can find you. So, what is given to us? What are our givens?
The moles.
Are the moles given to us?
Well, I mean, in the.
What was that? We have molarity and volume. So if we have molarity and volume, we can get moles, right? So. Let's start with the first one. We have barium chloride. So we have 275 milliliters of barium chloride. We know we have to change moles into lessons because we know that molarity is, what are the units for molarity? Moles over liters. So we need to change our milliliters into liters. So we do that by dividing it by what? Okay, so then we can use our concentration because we know that that's moles over liters. So then we can get moles. So we'll have 0.250 moles barium chloride over 1 liter of barium chloride solution. Okay, so then our liters are going to cancel out. Liters are going to cancel out. And then we would just get moles, right? But we want to take that one step further to figure out how many moles of our sodium phosphate we're going to need to react. Okay. Actually, we'll do it differently this time because it says how many moles of barium phosphate precipitate will be formed. So what we're going to do is we're going to find out how much barium phosphate we're making in this case. Because then, again, I told you I'm always looking for the easiest way out. There, we're looking for the product. Let's just go ahead and find the product for both cases. Okay. So if we do that, what is the ratio between barium chloride to barium phosphate? 3 to 1. Right? So for every 1 mole of barium phosphate, we're going to need 3 moles of barium chloride. Okay, it's going to be that heavy lifting.
Zero eight three three.
You said 0.0833. Okay. So I'll give you a chance to redeem yourself.
Wait, I think I got it.
Okay, what do you got?
I think I'm wrong, but I'm just gonna stop. Anyway, 0.022916667.
How many sig figs should I have?
3.
No, 3 sig figs.
Right?
3 sig figs.
Yeah.
Okay, so then my answer should be
0.02.
0.0. Is that to be say fix? 229.
That. I got that.
Don't forget your number of sig figs, right?
Yeah.
That will definitely be on the list. Okay, so if we have,
I mean, either I got 0.2.
okay, now we have to do the same thing. We have to use the moles of sodium phosphate.
That would be considered our B.
Just things that change. In perspective. Basically, this one's one, and this one's the other one.
Okay, so the next line, we're going to use the number of milliliters of our sodium phosphate. And we're going to do exactly the same thing.
Molarity.
Okay, so what is the mole to mole ratio of our sodium phosphate to our barium phosphate? It's 2 to 1. Put those 2 moles on the bottom for the barium chloride. Oops, sorry, wrong thing. Sorry, sodium phosphate. Again, that will be 1 mole of barium phosphate. You guys get.
I should have gone home.
Okay. Okay, so which one has a lower value? No, which one has the lower value? Because they're both barium phosphate. So that one is 0.0229, and the second one is 0.0141.
And then the
Okay.
bottom one,
Yeah,
we
that's
got.
It's barium phosphate. They're both barium phosphate. So in other words, we're looking for the moles. So remember I told you there's the long way of doing it, right? And then there's the short way, of doing it, right? So
I think it's, what do we got? I see where I put 100 square 1,000. That's why it is.
This is a long.
okay, so this is sort of the long way, but the thing is that it's, in the long run, it's shorter. Because if we had done it the other way, we'd have to compare moles to moles of, and get moles of what we want to what we need, right? But in this case, all they're looking for is how many moles of our precipitate. So they don't care how you get there. They just want you to give me what we're gonna end up with. What is the maximum amount that we can end up with?
Out of those two answers, which one?
It's always the one that's the lowest, right? Because it's kind of like think about it always like the cheese sandwiches, right? So how many cheese sandwiches can you make, right? If we had that 11 pieces of cheese and we had 28 or 30 pieces of bread, right? We had 30 pieces of bread and 11 pieces of cheese. What is the maximum amount of cheese sandwiches that we can make? Okay.
Yeah.
Yeah, so if we looked at the bread alone, how many cheese sandwiches can we make? If we had 30 pieces of bread, we can make 15 cheese sandwiches. If we looked at the cheese, where we only had 11 pieces of cheese, how many cheese sandwiches can we make?
That's why.
11, that's right. So the question is, how many cheese sandwiches can you make if you're taking both of them into consideration?
I don't see that.
You don't see that on the list?
Not on like what you.
It's exactly the same way. You always go with the one that's the least amount, right? Because if you went the one with the most amount, you're always gonna run out of the one that you have the least of. Does that make sense? Yeah, you gotta use what you have, right? Because it's about what you have. You can't, it's kind of like, okay, so I want $1 million, right? I can spend $1 million, okay? But I only have $1, right?
Yeah.
So am I gonna go out and buy a brand new house, a Porsche and everything like that if I have $1? Am I gonna buy, a candy bar that costs, I know. I can't buy anything these days, right? $1's nothing, right? So does that make sense? So you can only use what you actually have, right?
So I have a question. So when you would enter 0.04 for
That's right. It costs you $500.
fair enough. Knowledge ain't free no more.
That's right, it costs.
Because both of them go to the. They probably.
Does that mean?
Yes.
Okay, and I remember when I first started, I would do everything and to look at the projects, right? Regardless of what they were asking. And then I realized, especially on time exams, you're like, shit, I have an hour to take this exam, so I need to figure out the fastest way to do it. So then I learned, look at what they're asking. Yes, because that's gonna tell you where you need to go. It's the fastest way to get. Does that make sense? You buy at Starbucks?
Yeah.
Since I only have $1?
I'll buy you.
Okay, so how are you guys feeling on this? Better? Worse?
Yes, better.
Okay, better. And this one is, it's a medium. It's not a hard one. Don't worry about it. I'll make a hard one for you. They can.
All right, that's fair.
I like him.
That is
He's-
not- that's
Yes,
not
I
fair.
like him.
Nah,
He-
you're just talking. Don't listen to him, please.
Okay. So,
That's why, don't.
I'll do the math, but I got it wrong.
He's like, oh. And he's like.
Okay, so I'm gonna do a couple more things and then we'll take our break and then we'll come back for the lab. So today you guys are gonna actually be working with acids and bases. So you're gonna do a titration. So we kind of talked about that a little bit. We talked about how to calculate the pH, right? Did we talk about how to calculate the pH?
I was not here, so I'm not aware.
You're not aware? See, that's what happens when you miss, right?
What was it my fault?
I know. Okay, So, just a quick reminder. So when we're talking about pH, pH is going to equal the log of the concentration of the hydronium ion, or we often will just simply call it H plus instead of H3 plus, H3O plus. Okay. We know that the hydronium ion, and when we make reference to the hydrogen ion, they're the same. The only thing, the hydrogen ion is basically grabbing onto the water that's present. Okay. Did we talk about that? Yes?
Yes.
We talked about it? Good. Okay. Okay, so then this would give us, because this represents the concentration, and the concentration is usually done in molarity. So it will give us the molarity of our acid, essentially. Okay. Okay. So today you guys are going to be doing the titration of hydrochloric acid with sodium hydroxide. So you guys are going to need to make a solution that is 0.1 molar. We have essentially, we have 6 groups. Can you do me a favor? I need to get the 6 rods for each of the groups.
Oh, 6 rods for each group or 6 in total?
6 total rods. That's 6 total rods. Sorry. I said that you're going to give me $1 million for not paying attention to what I said. That's what I said. Okay. So today you guys are going to be doing an acid-base titration. So in other words, we're trying to make it so it's neutral. You guys are going to use 4 different indicators. One of the indicators that you guys are going to be using is going to be a very classic indicator that's often used in sciences at all levels, and that's fingernails.
Put
No,
finger in it.
No, you are not going to be putting your finger in that answer. No, you're not be doing it. Don't listen to him. Right? I said earlier, you guys should listen to it. I changed my mind. Okay. So you're going to be using cabbage extract. Cabbage extract, red cabbage extract, red cabbage extract is a natural pH indicator. It actually changes color depending on the acidic conditions. So often you can tell if an acid has been, if a cabbage has been mistreated or growth conditions are horrible based upon the color of your red cabbage, right? And so we're going to be using the red cabbage indicator for one. You're going to use another one called methyl orange. Okay, methyl orange. And then you're going to use another one called phenol flavonoid. Yeah, that's going to be your other one. And then you're going to use bromothymol. What's that? Oh yeah, I know. It's lab number 13. Lab number 13. Okay, so you're essentially going to do it 4 times. In addition to it, you're also going to be testing out our pH meters. So we're going to have you guys set up with pH at each of your stations. Yeah. Don't die. Why? Well, if you want to die, because you do drop it. Okay. So you're going to also be testing out the pH meters. The thing about the pH meters, once you set them up, they need to be calibrated. The problem is that we're very limited about the calibration solution. Right? And so you guys are going to have to share the calibration solution. So we're going to work it around. Okay. And you don't need too much. You just need to stick your electrodes in there and take it. You will also need to put distilled water in your bottle. Your water bottle. Okay. So what else did I tell you? So nice. This is for you, not for me. That's your niece? Did she talk you into taking the class, or did you talk her into taking the class? You guys didn't know? Oh, that is so fun. Okay. So what we're gonna do is we're gonna take a, we'll give you guys 15-minute break. So see you guys back here at 3 o'clock so we can get this done by.